Hello and namaskar. Everybody, it's me, Deepak Raj Bhatt, warms regarding from physics student in CDP, Central Department of Physics in Kirtipur. Today I'm going to do the virtual lab on the topics of experimental determination of Planck's constant using light emitting diode, a virtual lab experiment. I'm going to submit this my virtual lab to the Central Department of Physics, T1 University, Kirtipur, Kathmandu. Here is my contact number and my email address. Yes, on these topics, experimental verification and determination of Planck's constant, I have a flowing content, aim of the experiment in page number 4, abstract and their corresponding page, keywords, apparatus required, introduction, literature review, theory, methodology, observation, procedure, as well as limitation, advantage of virtual experiment, precaution, result, and their corresponding. These are their corresponding pages, and similarly, result in page number 12. And similarly, conclusion on page number 12, and acknowledgement, reference, appendix. At first, I'm going to clarify our briefing about the topics of aim of the experiment. Actually, the aim of the experiment to utilize the inquiry-based science education, means IBSE, which means in the field of science, so many students are curious about the different phenomena, but they didn't know about the actual meaning and how can we calculate the different parameter. Today, this practical help us to how to find out the value of this Planck's constant. This Planck's constant. The main aim of the experiment is utilized to inquiry-based science education in order to offer the student a better understanding of the light-matter interaction. Nowadays, I also clear by doing this virtual experiment about the relation between light and matter. This inquiry-based teaching addresses the question of how students make the observation, develop the hypothesis about the phenomenon, devise the test to investigate their hypothesis. Yes, to calculate this Planck's constant as a fourth year student of the university in Italy, they can calculate the value of Planck's constant by two methods. First one is the current voltage measurement method in a different series of the different color of the LED, and second one is the method based upon the comparison of incident light beams, which has a different potential value. And similarly, abstract. The main abstract or the main vision of the experiment is to determine the Planck's constant using the light emitting diode, and its value is nearly 6.626 into 10 to the power minus 34 joule second by using the different color of light emitting diode, which have a different wavelength, as well as the spectrometer and basis circuit analysis technique are also employed or also can do to obtain the empirical data to calculate the Planck's constant. This is the main abstract of this experiment, and nearly its value, we can find its value, means the value of Planck's constant is 6.67 into 10 to the power minus 34 joule second. The keyword used in this experiment is IBSE, which means inquiry-based science education. Means students have so many queries to do the experiment to calculate the value of the given physical phenomena. Yes, the main theme or the main vision of the experiment is this, and this is the keyword. And next, Planck's constant. Planck's constant is also next key word, and then similarly LED, light emitting diodes, and the photoelectric effect. Next one, photoelectric effect. Likewise, the similar given content, the content number 4 is apparatus required. For do this practical physically inside the lab, we need a 0 to 10 voltage power supply, power source, maybe battery or maybe from other device, a one-way key, and a rheostat, and a digital millimeter, and a digital voltmeter, and a 1 kilo ohm resistor, and a different non-wavelength LED bulb or diode. But in case of our virtual lab, we have a computer or a laptop set, a mobile, and or a well internet access. Similarly, the number 4 point of this virtual experiment is our introduction. The introduction of the experiment means from this experiment we should know about the interaction of light and matter, which is synthetically expressed by our Einstein-Planck's equation E is equal to Hn, where this n is our frequency and h is our Planck's constant. And today we are going to calculate the value of h, and n is the frequency of the photon. It represents a milestone in the introduction of quantum mechanics, because the value of this h is used in maximum among the all of the equation as possible. I think in quantum equation, the most probably appear physical constant is this h. So this is the milestone to the introduction of quantum mechanics, as well as the quantum theory or the quantum action in physics, as well as our chemistry also. It is one of the fundamental physical constant used to understanding the meaning of quantization in the atomic and the nuclear world, and represent the fundamental unit of the action for discrete atomic scale system. In atomic scale system, this H gives us the quantization. Quantization means the value of energy into the different level of atomic scale. And there is so many introduction I emphasized on this PDF, and there is also a literature review. The main literature review is the discovery of Planck's relation is generally regarded as the starting point of quantum physics. The Planck's constant H is now regarded as one of the most important universal constant, and the physical nature of H, however, has not been well understood. It was originally suggested as a fitting constant to explain the black body radiation. Although the Planck had proposed a theoretical junction of H, he was never satisfied with that. To solve the outstanding problem, we used the Maxwell theory to directly calculate the energy and quantum of a radiation wave packet. Likewise, in point number 6 in my PDF, there is a theory. The theory of Planck's constant is Planck's constant, physical constant, was introduced by German scientist named Max Planck he introduced this theory about nearly 1980. The significance of the Planck's constant is that quanta means small pocket of energy, means a pocket of photon, can be determined the frequency of the radiation and the Planck's constant. It describes the behavior of particle and wave at atomic level as well as the particle nature of light, that is dual characteristics, duality means dual characteristics of wave particle quanta, which has we show the both characteristics particle as well as the wave nature. This is uh, the main theory of the experiment, this virtual lab. We use a LED which has a two-terminal semiconductor light source. In the unbiased condition, a potential barrier is developed across a PN junction of the LED. When we connect this LED to an external voltage source in forward bias condition, the height of the potential barrier across the PN junction is reduced. At a particular voltage, the height of potential barrier becomes very low and the LED start to glowing. Means when we connect these our different kinds of LED bulb in the forward bias condition in PN junction, in the form of PN junction, then the potential barrier between PN junction is decreases and bulb start to glowing. That is, in the forward bias condition, electron crossing the junction are excited, and when they return to their normal state, means when the electron jump from lower energy level to higher energy level, means after return to their original state, they release their different kinds of the wavelength, means they return to their normal state and energy is emitted. During this situation, there are different kinds of wavelength may occur. This particular voltage is called the knee voltage. When the electron are excited and they get jump from lower energy level into higher energy level, after return back into the original means normal state, they release their energy. They release their energy in the form of wavelength, and this voltage, corresponding voltage to imitate the energy, is known as our knee voltage or threshold voltage. Once the knee voltage is reached, the current may increase, but the voltage does not change. The light energy emitted during the forward bias is given by our Einstein relation P is equal to mc and pc. I think from there pc and p is equal to s by lambda. So we write E is equal to sc over lambda, where c is the velocity of light, as is Planck's constant, which now I'm going to determine, which is remain to determine, and L is the wavelength of light, means this light of a different kinds of our LED bulb having different wavelength, and if V is the forward voltage applied across the LED, when it begins to emit light, the knee voltage means supply voltage is knee voltage. When bulb glow or the electron return to their original state, during that they emit their corresponding energy. The energy is energy to the electron corresponding the junction is given by E is equal to EV. This is our equation second, E is equal to EV. After equating this, E is equal to HC by lambda and E is equal to EV, small e, and potential voltage V, then we get equating equation first and second, we get EV is equal to SC by lambda. EV is equal to SC by lambda. And after dividing the E on both sides, we get this final equation. This equation number 4. This is our equation third. Now from equation 4, we on the basis of this equation, now we are going to plot one graph by observing the different value, by doing some observation, and we get a one straight line which is passes from there, and this straight line has a slope which is represented by s, and this slope gives the value of sc by e from this equation. So v is equal to sc over e 1 over lambda. If we plot a graph between this voltage and the reciprocal of this wavelength, we can get this straight line, and this sc by e gives us the slope, and this slope gives the value of Planck's constant by the help of this slope, and we already know the value of c, which is 3 into 10 to the power 8 meter per second, and e the value of electron 1.6 into 10 to the power minus 19 coulomb charge. And after separate this value of h from this equation, we get the final equation in the form of this this h is equal to e by c multiply s, where this s is the slope of this line, and the ratio of this ec is 5.33 into 10 to the power 28 coulomb second per meter. After substituting the value of electron, means the charge of electron is 1.6 into 10 to the power minus 19 coulomb, and the velocity of light is 3 into 10 to the power 8 meter per second. Then finally we get 5.33 into 10 to the power 10 to the minus 28 coulomb second per meter. Alternatively, we can write the equation 3 in the form of this: h is equal to e by c, and this s is equal to h lambda. From there, if we substitute the value of this in the form of this equation, sc over e, and after substituting this, finally we get this equation. Calculate for h for each LED and take the average of our result. We do this in our virtual lab. Now we enter into our virtual lab. This is the methodology for virtual lab. We have only one simulation, and this is our simulation. This is our battery, and we should connect the experiment by this way, by where we click the arrow, means this cross of our mouse into the given this red color, then they means it help us to where we connect this wire. Okay, in this way we can do this virtual experiment. And after connect this all wire, means after complete this circuit look like this types. Okay, we have given to so many procedure here. First of all, after the connection are completed, click on insert key. These all are found in our virtual lab, and click on the combo box, means this also appear in our virtual lab. So now I'm going to enter into our virtual lab. For doing virtual lab, we know about the web browser, this address blabs.amrita.edu. Then we have then after that we also click on our email address for performing this virtual lab. After then we found there like one of the option, like chemistry lab, physics lab, bio lab, bioengineering lab. Then we should click on our physics lab. Okay, then we get this in our virtual lab. Now I'm going to do this virtual lab, okay, on the topics of our determination of Planck's constant. We have given theory here. Okay, if we click on there, we can find the determination of Planck's constant, apparatus required, theory. Okay, and we have also procedure on this option, and how to connect, and how can we do this this virtual experiment we have given here, and you can do this practical from this way also. Now I enter into the simulator, and this also need login. Okay, and for that we choose our Google Gmail. So I click on here, and after rolling it, and now I enter into the simulation option, simulator. Now now I'm going to click on this and this line, and after click on there, we have option to choose the different color of LED bulb, because we need a different wavelength. This is the wavelength, value of wavelength, such as like red LED has a wavelength 650 nanometer, and green has a 510, means 510 nanometer. Yellow has 570 nanometer. Similarly, blue has also a given value around the, I think, 475 nanometer, and infrared also has a high uh, wavelength 1100, like something that. Okay, and after choosing these different diode, before we choose this LED, first of all, now I'm going to complete the given circuit. First, now I'm going to click on here. After click on here, we have option. We have seen an option in our virtual lab. So I connect this wire from here to here. Similarly, if we connect on here where the finger pointed arrow is appear, then I connect this wire to here to here. If there is no connection, then we will try again. Similarly, now I'm going to connect this rheostat from there to our voltmeter. I think this is our ammeter, sorry, ammeter. And after that, now I'm going to connect the ammeter into resistor, and resistor into LED bulb, and LED bulb, sorry, click on here, and finally collect on here, and finally, and I'm going to complete the circuit, LED bulb to our battery. And we have also remained to connect our this battery into rheostat. These all are included in our procedure. Okay, if we read the procedure properly, then we should know about the knowledge how to connect, where it is connect. Now I'm going to again complete this circuit, this our voltmeter to LED bulb, and similarly this voltmeter into LED bulb. There is also a complete circuit. If we take the pointed arrow in the given device, we can see the option if there is remaining to connect the given point. Okay, this is our complete diagram of our virtual lab, which we see in our previous PDF. Okay, this look like this. Okay, this is the complete diagram. Yes, this diagram also, this is the circuit diagram. Now I'm going to do this observation and taking the different values, taking the different data from the observation. Yes, and I'm going to enter in our virtual lab. Yeah, now we click on here, and we have given different variables. Now I'm going to choose the LED bulb at first, red LED, which has a 650 nanometer wavelength. And now I'm going to adjust. First, we click on here insert key, because we see here the circuit is complete, and it is ready to taking the different practical or picking some value from there. Okay, now I'm going to adjust the rheostat. Suppose in my experiment I adjusted the value of rheostat is 200. So now I'm going to adjust. It's the value of rheostat is 200 ohms. And if we click on here show result, then we found here result. Wavelength of LED is 615 nanometer, which is our red LED light emitting diode, and the value of Planck's constant is 6.566 into 10 to the power 30 minus 34 kg meter square per second. And now I'm going to take the observation. First, we write here red, 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 and the value of this red LED means 650 nanometer, wavelength in nanometer, and the knee voltage. For taking the value of knee voltage, we choose the value of knee voltage from here, 0.9. So we write here 0.9. This is our knee voltage, and after picking this value from the given data, and after click on here, we get the value of lambda v, and we found here value of lambda v, and we also need this value of lambda v in our observation. So I write this value on here, 5.85 into 10 to the power this e to the power, this in the form of e means electron, value of electron, because we can, if we write this in the form of e to the power something, then we can easily calculate the value of as our required in the given relation. So I write the value in same form which I get in our experiment. And we also found their corresponding means this is obviously know the value of charge of electron, velocity of light. So to calculate the corresponding edge, we also write here, type here some value which I obtain in our knee voltage here, and we also copy from there to there. Then we also found the corresponding value, and finally we get the value of Planck's constant is 6.6 knee voltage 0.9 here, and 5.85, and their corresponding value of Planck's constant is 6.6264 into 10 to the power 34. Okay, and this is the nearly means closely related to the hypothetical value of Planck's constant. In this way, we also do the same procedure for the next wavelength, means our next bulb, LED bulb. Okay, next diode green. Okay, green has 510 nanometer wavelength, and if we adjust the rheostat nearly 200, 200, and the given diagram is look like this. And if we click on this show result, and we get the value of Planck's constant is 6.566, which is nearly different than previous, but relatively close to the our hypothetical value. It's good for us. And we also write here for which our green, yeah, we type their green, GREN green, and their corresponding wavelength 510 here, 510 on here, and knee voltage is look like previous result. And after click on here and here, and we get the value differ that our previous observation, means on our red light. Okay, we get here 4.59 into 10 to the power -7. This is our charge, and as the same we found here, if we click on there 0.0, yeah, this is our knee voltage, and this is our charge of the electron and velocity of light. And finally we get here the 6.626 into 10 to the power 34. In this way, we can pick up the given data, and we should place on the observation table, and finally we get their corresponding value. I'll multiply lambda putting here, and finally the value of h in the form of here, and nearly its value is our hypothetical value. This is our observation for doing the virtual lab, and this is the way to calculate. If we need to print, then we click on here, then we can also get the print. Okay, and for saving this data we can click on here, and if we need a print uh, doing the observation or by keeping the record, we can also click on here. In this way we can do this our virtual lab uh, by this way for uh, other like yellow, blue, and infrared, and we get the different corresponding value. Now I'm going to return my PDF. Okay, and this is my observation table, and I take this some their corresponding values like wavelength in nanometer, knee voltage in the form of volt, and their corresponding multiply this L into lambda into voltage, then we get the different value on here, and after calculating we get the similar result as in my screen. And if we do this virtual lab in our physical lab, we can also calculate by following the uh, flowing procedure. I also mentioned here. Yeah, actually, what is the advantage and how many advantage? There is no limit advantage for doing the virtual lab nowadays, I think. But among the all advantage, I only mentioned here 6 advantage about the virtual lab. It satisfies the scientific passion of the student like us by flowing the conduct a different experiment regardless of time and place, for doing different kinds means like different practical. It is impossible for performing to do the practical physically with the different lab. Okay, but nowadays we have facilities to do this virtual, to do different kinds of practical in virtual lab. It saves our time and effort. Okay, and it also gives us the record of the different result, and student can conduct the same experiment multiple times, which is not generally possible in our laboratory. It will help it will help the student to get the familiarized with the modern tools and the simulation techniques. It enables us to display the accurate phenomena that may not be measured within the simple laboratory tools. Limitation. Although we have so many advantages, there are some limitation. They are as follow. For the virtual lab, student must have a computer. It is too difficult nowadays because it is too expensive nowadays. Uh, it is very difficult to visualize the experiment using mobile phone. Yeah, in earlier day, before I have this computer set, I was try with the handset cell phone, but it's impossible. Really, I cannot able to. I was not did any virtual lab with the help of our mobile set. This is the limitation. Proper internet connections should be available, but in the most of our hilly and mountain region of Nepal, internet facility is still a challenge. There is weak internet access. For doing the virtual lab, we need a very well internet access. The student may not uh, get the same confidence as in laboratory. Yeah, exactly. I realize it because if we do, or if we conduct the experiment by touching the different physical like this uh, equipment or these tools, then we realize, then we remember for a long time. But the virtual experiment is really facing this our problem, and which look like this our LED, different LED having different color, and what is the physical shape of the rheostat, and this like other equipment or tools to do the experiment. Yeah, it is really uh, low confidence. It gives us low confidence. Physically practical skill may not be developed. Precaution: what we should do before do the practical, I mentioned here. Proper connection must be done, otherwise the result may not get the desired form. And appropriate resistor for doing the this our practical means this is my determination of Planck's constant. I need a 1 kilo ohm resistor. Yeah, this is important point. And result: by using the different wavelength of the LED, such as red, green, yellow, infrared, we get the equivalent value of Planck's constant. Moreover, we also know the interaction between the matter and light. Yes, from this experiment, we should also uh, know the idea about matter and light. Otherwise, it is worthless. And Planck's constant as a physical constant was introduced by a German France physicist, German physicist Max Planck, in 1980. But nowadays we can also calculate by virtually. Experimentally, its value is nearly 6.62 into 10 to the power minus 34 joule per second. Joule second, which is nearly equal to the hypothetical value. Conclusion: within the framework of a master of the dedicate of science, the authors respectively a chemist and a physicist offer their student to different way to measure the Planck's constant as measure of energy of the photon emitted by LED diode and the study of the photoelectric effect induced by the light emitted from the mercury lamp. The author involved the student by using the uh, inquiry-based uh, inquiry-based science education or science study, science education or inquiry-based methodology in a series of the activities of the observation, exploration, construction of the circuit, adjustment of the optical bench, use of computer equipment, data processing, analyzing of the error, which allowed them to acquire an experimental mode to calculate the Planck's constant. This is the conclusion. Yeah, we have given a different sources on here. This Amrita University lab, B lab, I mainly follow this web address and I perform this experiment. And we have also given the different address or reference from where we can do this experiment, and at last appendix. And I also write here acknowledgement. uh, I would like to express my acknowledgement to all my faculties, seniors, laboratory supporting staffs, administrative staffs, all my classmates, as well as to whom it may concern, and special thanks to our HOD, Central Department of Physics, for providing me such a great opportunity to have a unique experience of doing virtual lab. Nowadays, I really uh, like in excited form, because I did not know about the any virtual lab, conducting a virtual lab, and how can I do the research or practical or the in our virtual lab. Nowadays, I'm clear, and still I became a perform to in physically doing physically in our laboratory. But I gain some knowledge, and it makes us happy to do or to research in other our desired field. I write here among the so many question answer, Viva question answer. I keep some question. I think nearly 6 question about the related to our this Planck's constant. The first question is how Planck's constant is determined. Planck's constant is determined by using the light emitting diode. Okay, insert in one way answer, in one word answer, in one sentence answer. How can we calculate the Planck's constant? Means we can calculate the Planck's constant by using light emitting diode. The LED work on the principle of semiconductor diode to flow the current from a N to P types of semiconductor, and minimum potential is required to do this experiment. How LED works? An LED bulbs produce light by passing the electric current through a semiconducting material. The diode which then emits the photon. Through this principle, LED work out. And next, which metal is used to made a LED? This is curious question, so I withdraw this question from a different network whether, and I keep on here. The material used most often in LED is gallium, arsenic, though there are many variation on the basic compound such as aluminum, gallium, arsenic, and aluminum, gallium, indium, and phosphide. What is Planck's constant related to? Planck's constant related, or it says how much energy of a photon increases. Yeah, that's a important or key point. This it should keep in mind. I think the Planck's constant say how much energy of a photon increase when the frequency of a photoelectric wave increase by 1 unit. If we increase the frequency of photoelectric by 1 unit, then if we multiply this frequency with the Planck's constant, then we should know the idea, or we should generate about the energy of the given photon. It is named after a physicist, Max Planck. The Planck's constant is a fundamental physical constant in our quantum physics. It is written as in the form of small letter h. What is Planck's constant experiment? What is Planck's constant experiment? Planck's constant experiment must be one of the most used in modern physics. This experiment uses the photoelectric effect and Einstein equation to measure the value of Planck's constant x. The box also contain a class set of LED. And is why is LED used to determine the Planck's constant? Why we used LED? Because in LED it has a different ranges of wavelength, and which help to calculate the value of h by easy way. We use LED in the experiment because each color of LED has a different threshold voltage at which electron start being produced, and measuring this voltage together, we know the value of the emission wavelength. Okay, this LED glow in a different voltage, and we keep the record of this different voltage, which is known as the threshold voltage, and which is being produced. And measuring this voltage together, we should know the value of the emission wavelength, and by this way, we can calculate the value of constant. Okay. Once again, I want to thank you to everybody to concern to our this virtual lab in our faculties. This is my virtual lab experiment on the topics of determination of Planck's constant. Once again, at last, uh, I I want to thank you and to all my friend as well as my classmate, and special thank to, again I want to say special thank to our HOD who gives us this great opportunity in leisure period uh, to do this virtual experiment to gain the different knowledge. And we I think we are facing this so many experimental experimental problem to conduct the different experiment. Nowadays it facilitate our desire to calculate or to do the virtual, to do the experiment virtually. So I want to say special thanks to our HOD, Central Department of Physics, and all the member of our university. Okay, at last I want to say thank you everybody, and only this much for this time. Okay, have a good time.